Hello everyone, welcome. Can you hear me?
Yes, sir.
Okay.
Recording in progress.
So I share my screen. Can you see my screen now?
It's visible.
Okay. So first of all we start. So hi and welcome the second day's training session on Google Earth Engine for beginners. So I am course coordinator and basically this is our second day. Second day's course content will be that I will discuss about the today I will discuss about the filtering and visualizing the satellite images. So mainly in this time I will discuss about the Landsat imagery, so how you can easily filter and visualize the Landsat imagery using the Google Earth Engine platform. And last day I also try to show you the about the Sentinel. Okay, then also discuss about how to export the satellite imagery. Suppose you want to create or filter and visualize a satellite imagery Landsat, so how you can easily export the satellite imagery, and you can easily use the satellite imagery with other geospatial software, just ArcMap or QGIS. Okay, then analysis of the Ndvi, how you can easily make the Ndvi time series chart. So mainly in this time here I use the Ndvi, but this process is the same for all of the dataset, Ndwi or other dataset, which dataset will be available in Google Earth Engine data catalog. We can easily export, we can easily make the time series chart using this method. Okay, okay, you can ask me, no problem. If you have any question you can ask. So mainly biomass carbon, we can easily get this dataset using the MODIS satellite imagery for the biomass, for estimating the biomass and carbon. No, so actually in this time I already published our course content. All of the course content I already published. Actually this is the course content only for the beginners, and after this if you need the any specialized topic, if you need to learn, you can also learn with me, no problem. But in this time we also cover all of our course content which I already declared in our leaflet. Okay, but if you have the own idea I hope you can easily do it. Okay, but basically this is the same process for all of the data set. Okay, so you can try, I hope you can understand easily. So if you when you want to work with the MODIS Ndvi, then you can easily work with the MODIS biomass carbon. Okay, I hope you understand. And this is the same thing for all of the things. Suppose MODIS Ndvi, MODIS Ndwi, MODIS biomass carbon. Okay, all of the process will be same. So then I also try to discuss about the Ndwi calculated from the MODIS and Landsat data, how you can easily calculate the Ndwi for a particular region. Okay, and then how to export the TIP images. Okay, so and then how to export any shapefile from the Google Earth Engine platform. Okay, so basically before starting, first of all I will complete it our the first day training session something for the reprojected the scale factor. Okay, then we will move to our today's class. So I simply open my code editor. You can see here I already open our code. In this code, mainly in this time here I use the MODIS Ndvi dataset, and we calculated the mean Ndvi data with this time period, but it has a problem. this problem is that this data set is not reprojected. Okay, so you already know about the Ndvi value, this range between -1 to +1, between this range, but we can get this data pixel value. You can see when I want to check the pixel value any portion, you can see it is not our range. Okay, this it's not including our range -1 to +1. Okay, so first of all, this data set is not reprojected. Okay, so in this time our first challenge is that first of all we make it reprojected our scale factor, then we easily do it. Okay, so first of all, you can see here I want to check, you can see this is the filter Ndvi. Okay, so I want to check how many images will be available in my filter Ndvi between this time period. Okay, so you already know about this function print, then I simply use here the filter Ndvi. I just simply copy and paste here. I simply use here the size function. Okay, then simply click to the run. So now I want to get how many images will be available between this time period. Okay, here you can see we can get total 115 images, but these images is not reprojected. Okay, so now I want to reproject it this scale value for all of the 115 images, and then I work with it. Okay, so first of all I can simply take a variable in here. I simply take a variable and I simply give the variable name is the scale Ndvi. You can use any variable name. I can simply use here the scale Ndvi. Okay, so in this time you can see here I want to make a function so that this function will be multiply with this scale factor. So you can see here this is my datasheet information sheet. So when I simply click to here, from this I easily get my data information sheet. You can see for the Ndvi it has a scale value. You can see this is my scale value. Okay, for the Ndvi 0.001. so this is my scale value. So in this time I want to make a function so that this function will multiply with this scale factor 0.001. Okay, 0.001 it will be multiply with the total 115 images. So in this time I want to just multiply my scale factor 0.0001 with my 115 images. Okay, I just multiply this and then it will be reprojected and I can get this result between -1 to +1, this range. Okay, so in this time I want to just multiply my whole collection 115 images. In this time I want to multiply with this 150 images. I just multiply my scale factor 0.0001, so then it will be reprojected. So for the multiply I want to use a function, so I simply use a function, and we already know about the function. So when you want to create the function you can simply use here the function keyword. So you can see I already defined my function variable name, then I use the equal sign, then I simply use here the function keyword. Okay, this is my function keyword, and we already know about that function keyword. After you use here the parenthesis, this parenthesis you can define your element name. In this time I need a element so that this element will be multiply with my whole collection. So in this time I simply gave the element name is the img or image or whatever, you can use any element name. Okay, then I simply use here the curly bracket, and between this curly bracket I define what is my argument. My argument is that the total 115 images it will be multiply with my scale factor 0.0001. So that's why my it will be reprojected and I can get this result between -1 to +1. So you can see here, you can normally think about that. I simply take a function, I can give the element name image. So element name, actually this is my variable name. Okay, image. I want to multiply this image. So you can remember that this image is equal to 115. You can just thought about that this image is equal to 115, or you can also say that this image is a variable and this image variable stored the total 115 images. Okay, so now I want to just multiply, so I want to return, I use here the return function. What I want to return, I returned this image. So this, what is this image? This image is stored total 115 images. So I simply use here this image. It means that it stored total 115 images, and I want to multiply, I simply use here the multiply with my scale factor. It is the 0.0001. Okay, so I hope you understand this part. So you can see here, now you can arise a question. So your question is that you can say that, you can see this is the another code, okay, and this code has the no relation with filter Ndvi. Okay, so you can see that what is the image, it while it come from this, you can see this is the totally another code, but it has the no relation with the filter Ndvi. Okay, so now I want to connect this. So now I created this function, you can see I create this function. So now I want to just connect this function with filter Ndvi. We can connect this function, you can see this is my function, I want to connect this function with filter Ndvi. So that's why when and this is the rule, when you want to make a function, so now you want to connect this function, then you need to use a function, it's called the map function. Okay, so I simply use here a function in here, map function, and then I simply, you can see this argument is the algorithm. You can see what is your algorithm, algorithm is your function. You can simply use here the map function, and then you can simply copy your function variable name. I simply copy and paste here. Okay, so you can see here this is my function, and now this function added or connecting with my whole collection filter Ndvi. So that's why I simply use here the map function. Okay, okay, so now you can see you need to also use another function, it called the copy properties, and then you define your element name image, and also you define here the system time start and system time end. It means that when you write this code, you can see in this code I already defined a time. Okay, you can see this is my start time and this is my end time. I want to reproject it my image, I want to reproject it my image, which image I want to get from this time period. Okay, so that's why I simply define here the system time start, as well as also define here the system time end. Okay, so now you can see here this is my function. Okay, this is my function, and I want to write this function, and after all this is my function, and now I want to add this function or connect this function with my whole image. My whole image is that you can see filter Ndvi. Okay, so I simply use here the map function and then copy the scale Ndvi, because this is my function variable name. So this is the one way. Okay, and another way is that I also try to show you this part so that you I hope you don't have any confusion about this. Okay, so if you have any question, you can ask me between this function create or add, connecting this function. Any question you can ask me. Anyone? So it's very easy. You can see here I just create a function, and in this time I want to connect this function with my whole collection filter Ndvi. So you can see I simply use here the map function, and then I can copy this function variable name. So return is that, you can see here return is a function. It means that what I want to get, what I can get from this function. In this time I want to need, so that this image will be multiply, with my whole collection. Okay, and you can see here this image, this is the element, and this element is stored total 115 images. How it will be stored, you can see. So that's why I simply use here the, when I use the map function, then it automatically stored the total 115 images. And return, and every function when you define any function, not only for this in here Google Earth Engine platform, when you define any function, then you use the return function. return is your final code, or what you want to need, or what you want to back from this function. Okay, so that's why I simply use the return, and I want to return from here so that the image multiply with my scale factor. Image is not defined. You can see here, good question. You can see here, this is the image, this is my element name. Okay, and this image is not defined because this is my element name, and when I use the map function, then it will be automatically defined. Okay, so in this time you can see here, between this curly bracket, I do everything using the image. You can see this is the image, I also use here the image, all of the tasks I will do using the image. Okay, so when I connect this function with my whole collection using the map function, it automatically take this image as a your 115 images. Okay, so this is the power of map function. Okay, so you can see here, this is the one way. So this is the one way. Suppose when you want to make a function, you just created a function, and then you can simply use the map function and using here the function variable name. So this is the one way. And another way is that, you can see, I will try to show you the another method. So I simply remove it. You can see here, I just simply call my filter Ndvi, call this filter Ndvi. This is my variable, because this variable is stored total 115 images, but this images is not reprojected. In this time I want to reproject it, so that's why I simply call the filter Ndvi. I copy and paste here. Okay, after this I simply use here the map function. Okay, map function, and then I simply use here the parenthesis, also use the parenthesis. This is the same method. Okay, you can see here, in this time I created this function. Okay, so now I also want to connect this function with total 115 images, and 115 images it will be stored in a variable filter Ndvi. So that's why I simply call the filter Ndvi, then use here the map function. Map is a function, it will be connecting your function which you created, it connecting with your overall collection. Okay, so you can see here, this is my function, and now I want to connect this function with my total 115 images. It will be stored under the filter Ndvi, so that's why I simply use here the map function. Okay, this is the same way. Or if you want, you can also connect this, write this function, and then you can simply use here the map function and write your the variable name, function variable name. It will also okay. So this is the same way or same process. Okay, I hope you understand this part. Any question? Any question or any doubt about this? Okay, so now I want to check how many images will be stayed after filter is reprojected scale factor. I want to check how many images will be available. So I want to check it. Simply use here the print function, and then I simply call my scale Ndvi, this variable. I simply call and paste here. After that, simply use here the size function, and then you can see how many images will be available in here. We can get the same image. Okay, you can see after the reprojected we can get the total 115 images, and when I also reprojected I can get the same 115 images. In this time, this is this value 150, this is not reprojected, and this value is reprojected. Okay, because I want to multiply with my scale factor. And suppose when you want to work with the MODIS, land surface temperature data, here you can see this unit is the degree Celsius, Kelvin. This unit is the Kelvin, but you want to need the unit in degree Celsius. So you can just create this function and just write the equation. What is the equation for the convert from the Kelvin to degree Celsius? Then it will be okay. Okay, this is the same way. So in this time here you can see I can get total 115 images, and this image is the reprojected or reprojected our scale factor. So now I want to calculate it all of the things using the scale Ndvi. Okay, so I simply copy and then paste here, and all of them will be same. I simply click to the run. So you can see I can totally get a white color map. You can see I can get a totally white color map. So can you guess it why I can get the white color map in this time in here? Anyone can guess it? And if you want to check the pixel value from here, you can see we can get the pixel value between our range -1 to +1, this range. But why I can get the white color map in here?
Did not use visualization parameter.
Yeah, so you can see here I use the visualization parameter, but in this time you can see here, in this time I want to show my result the -1 to +1, this range. So that's why I reprojected. But you can see here it will be showing the mean pixel value from the 0 up to 8000. Okay, it will be not messing with our range of our pixel value range. So that's why we can get the white color. So I simply change it. I want to get the range between -1 to +1, or what range you need, you can just put here 1 to 0.5 or 0.5 to 1. Okay, then we can get the all of the pixel value, you can see. So now it will be okay. So now we can see this map visualization is good. So now we can see this is the Ndvi map between this time period, and this result is also reprojected. If you want to check from the any place, we can get the result within this range between the -1 to +1. Okay, and now if you want, you can also export this map as a TIFF format and work with the ArcMap or QGIS software as a Ndvi map. Okay, so I hope you understand this part, and we also covered this part for the exporting when I also covered the Landsat or Landsat filtering the Landsat, this part. Okay, so any question in this time in here? Any question? Okay, so we will start our today's session, and then we also come again in here for cover the
How to get the graph of time series.
Okay, I also covered this today, no problem. We also cover all of the things today for that, make the time series chart or everything. Okay, no problem. Okay, so we will start our today's session. Okay, so I simply open my slide. So first of all, filtering and visualizing the satellite imagery in Google Earth Engine platform, and this is the same way for Landsat as well as Sentinel. This is the same process for filtering and visualizing the satellite images. Okay, and it is the one of the most fundamental part of Google Earth Engine is selecting and filtering the image you need and display this image on the map. And Google has already selected a wide variety of public data set. Okay, we can already talk about the Earth Engine data catalog. Okay, so we can, when you want to filter the satellite images in Google Earth Engine platform, we need to filter these images some factor. Okay, suppose I want to need the Landsat satellite imagery for my specific region, for your specific region of interest. So region is one factor. So when you filter the satellite imagery, first of all, you thought about that your region. Suppose I want to need the satellite imagery for the region of Dhaka city. I want to need the Landsat imagery for the region of Dhaka city. Okay, so region is a factor. Your region vary from your different types of ROI or region of interest. Okay, so this is the one factor for filtering. Another factor is that image properties. Suppose I want to need these images, I want to need only for the for those images which image will not be more than 1% cloud cover. So this is the image metadata or image properties. Okay, so this is the another factor for filtering. First factor is the region, second factor is the image properties, and third factor is that a specific time period. Suppose I want to need the images only for the year of 2017 or any time period what I need. Okay, so when you want to work with the Lancet or Sentinel, you always filter according to this factor. Okay, so we will start. So I will give the practical example so that you can easily understand all of the things one by one. And after 4 minutes this meeting will be end. So then I also send you the Zoom link again, so please join. Okay, okay, so I open my code editor. So I simply open a new code editor in here. Suppose in this time I want to work with the Lancet 8 top of atmospheric reflectance, this collection. Okay, so I simply, you can simply search in here Lancet 8. Okay, top of atmospheric. Okay, so in this time my network connection is not good, so that's why it will be not showing the result. Okay, so no problem, we can also export the dataset another way. So I simply browse my data catalog. So now it will be going the data catalog of Earth Engine data catalog, and from this we can easily access Lancet. So you can see this is the Lancet. I simply click on the Lancet. Here I can get all of the Lancet collection. You can see Lancet 9 surface reflectance, Lancet 8 surface reflectance, Lancet 7 surface reflectance, Lancet 5 surface. All of the collection will be same. Okay, so it's depend on your remote sensing work. Okay, suppose you want to work with the top of atmospheric, sometimes this top of atmospheric is better for the specific remote sensing work, or some remote sensing work for the better for the surface reflectance. So it will be depend on your remote sensing work which you want to perform. Okay, but sometimes you can see, suppose you want to check, sometimes the surface reflectance there is the low cloud, but top of atmospheric we can get the some lot of cloud. Okay, so it will be depend on your research work or project work. So in this time I want to work with the top of atmospheric data set. So here you can see Lancet 8, I want to work with this. Also you can see Lancet 9 or Lancet 7. Also you can see their time duration. Okay, so all of them will be same. All of them will be same. So in this time I simply open with my Lancet 8 top of atmospheric, this data collection. Here I can get all of the information. Here I can get all of the information about the Lancet 8. Okay, top of atmospheric reflectance, this data set. You can see this is the data set availability date. Okay, also you can see data set provider USGS and Google. And when you want to work with the not Earth Engine data catalog, then we can traditional way we can download the satellite imagery from the USGS or Earth Explorer, this website. Okay, but you can see here they are already provided this remote sensing data or satellite data. They are already provided in Google Earth Engine data catalog. So in this time I want to just work with this data set. Okay, and this is the same data set which if you want you can download this data set from the USGS and from the this is the same. Okay, totally same. So in this time I want to work with this data set. One way is that you can simply search and click to import. This dataset will be imported. Another way is that you can simply copy this collection snippet. So this is the Earth Engine snippet. I simply copy from here. After this I simply paste here. Okay, and I also provide a variable name. I simply put the variable name is that L8. So here you can see this is the L8 and this is my collection. Okay, this is my full collection of the Lancet satellite imagery. Okay, and it will be stored in a variable. This variable name is the L8. So in this time my Lancet Lancet satellite imagery, it will be imported. This dataset will be imported in my code editor, and now I work with it. Okay, so now it will be imported. So first of all, we will check how many Landsat image will be available for the whole world between this time period. Okay, I simply use here the print function, and then I simply use here the L8 and use here the size function. You can see we can get the large number of collection between the whole world within this time period.